Now here we proceed to learn how to write the equation of the pair of tangents to an ellipse from some external point. So suppose we are given some point, say x1, y1, which is lying outside the given ellipse, whose equation is, we know the standard form, that is x square upon a square plus y square upon b square equal to 1. Alright, so clearly we can see that we can always draw two distinct tangents from the point. So it forms a pair of lines, that's a pair of these tangents, whose joint equation is given by the formula t square is equal to s into s1, where we have to understand the meaning of these code words, what is t, s and s1. Alright, now let us first see what is s. Okay, s stands for the equation of the ellipse in which all the terms are taken on one side and 0 is on other side. So if you see the equation of the ellipse is this. So s stands for x square upon a square plus y square upon b square minus 1, because you want the 1 on the left side so that there is 0 on the right side. Okay, so this particular expression is denoted as s. Then let's consider what is s1. Now s1 is nothing but the expression of s in which we substitute the coordinates of the external point in place of x and y. Okay, so in this same equation x and y will be replaced with x1 and y1. So here we get x1 square upon a square plus y1 square upon b square minus 1. So that becomes s1. And now what is t equal to? So t equals the equation of the tangent to the ellipse in general form, and in that also we want 0 on one side. Now if you recollect the equation of the tangent, it was x1 upon a square plus y1 upon b square equal to 1. So therefore clearly bringing 1 on the left hand side, we will get the expression as x1 upon a square plus y1 upon b square minus 1 and the whole square. Okay. Now few important points to be kept in mind, or that must be carefully understood, is in case of the tangent, when we say that the equation was t equal to 0, and in that case the x1 y1 was the point on the ellipse where the tangent is drawn. Okay, now we use the same pattern here, but it is only for the expression, okay, and not the point, because in this case when we are considering the pair of tangents, the point x1 y1 is an external point, right? It's not the point on the ellipse. So therefore the interpretation of x1 and y1 is different in both cases, although the pattern of the equation is exactly same, which we denote as t. Okay, so that is to be kept in mind. Then secondly, from where this particular joint equation comes. Okay, so for that what we have to do is we have to derive that, considering the point, if we write it in the equation of the tangent in terms of slopes, we will get a quadratic equation in the slope, that is m, whose two roots will be nothing but the slopes of the two possible tangents. Okay, and from that we simplify and get the equation. So it's basically easy if you remember this particular final form directly, which can be used in the examples. So let's go ahead and solve an example, that is find the joint equation of pair of tangents from point 4, 5 to the ellipse x square plus 4y square equal to 4. Okay, now let us first of all bring it in the standard form. So the equation of the ellipse is x square by 4 plus y square equal to 1. So therefore x square by 4 plus y square minus 1 equal to 0. Correct. So this is our s. Right. So now to calculate s1, we will have to replace x and y with 4 and 5. So therefore 4 square is 16 upon 4 plus y square is 25 minus 1. Okay. This is our s1. So therefore, which is nothing but 4 plus 25, that is 29, minus 1, that is 28. Okay, so therefore S1 is nothing but 28. Now next we have to write the equation of the tangent, which is x(x1) upon a square plus y(y1) upon b square equal to 1. Now here if you see in the original equation, the b square was nothing but 1. So once again let us put x1 and y1 as 4 and 5 respectively. So we get 4x upon a square is 4 plus 5y upon 1, and then let's bring the right side 1 on left side. So therefore we get x plus 5y minus 1 equal to 0. So therefore here the left hand side becomes t, that represents t. Now the joint equation of the pair of tangents is given as t square is equal to s(s1), and hence we get x plus 5y minus 1 the whole square is equal to s and s1. s1 is 28, so we can write that s1 first. 28 into x square upon 4 plus y square minus 1, which we can simplify and get the most simplified form, but that's the equation of pair of tangents.